Good morning, students. Last class we discussed about the reference electrode and electrochemical cells. Now today we will discuss about reversible cell reaction. According to electrochemical cell, we discussed about the Daniell cell. Here this is a construction of Daniell cell. Zinc rod is dipped in zinc sulfate solution. Copper rod is dipped in copper sulfate solution. Both the solutions are connected with the salt bridge. Both the electrodes are connected with a voltmeter. External circuit is with voltmeter. Now the reaction is zinc rod dissolves in zinc sulfate solution by releasing of electron. So flow of electron from zinc to copper, flow of current from copper to zinc. So flow of electron from zinc to copper, flow of current from copper to zinc. Then this reaction will continue when this voltage value reaches to 1.1 volts. Then the EMF value is equal to 1.1 volts. Then the condition is, if it is reaches to 1.1 volts, then reaction will stop. If it is less than 1.1 volts, reaction will continue. The reaction is zinc rod dissolves in zinc sulfate solution. Then passage of electron, flow of electron from zinc to copper, flow of current from copper to zinc. This reaction will continue till the voltmeter reading is 1.1 volts. If it is reaches to 1.1 volts, reaction will stop. Then third one is, first one is, if the voltage value, EMF value is less than 1.1, reaction will continue. Second one, when it is reaches to 1.1 volts, reaction will stop, cell reaction will stop. Third one, if we apply external voltage, that is more than 1.1 volts, if it is more than 1.1 volts, then cell reaction is reverse. That is called reversible cell reaction. Again, according to Daniell cell, zinc rod dissolves in zinc sulfate solution, copper rod dissolves in copper sulfate solution. The cell reaction is, here flow of electron from zinc to copper, anode to cathode. Flow of current from copper to zinc. This reaction will continue, then the potential is equal to 1.1 volts. When it reaches to 1.1 volts, cell reaction becomes stop. If the external circuit, if we apply the external voltage, that is more than if it is 1.1 volts, the cell reaction become reverse. The cell reaction become reverse means copper rod releases the electron, then flow of electron from copper to zinc, flow of current from zinc to copper, flow of electron from copper to zinc, flow of current from zinc to copper. So this is called reversible cell reaction. According to Daniell cell, this is the reaction. When it is less than 1.1 volts, zinc is converted to Zn+, so Zn is converted to Zn+, to oxidation, Cu+2 is converted to Cu. When if the external voltage is more than 1.1 volts, cell reaction is reverse. The real reverse means Zn+2 plus Cu gives rise to Cu+2 plus Zn. This is about reversible cell reaction. Next we will discuss about the important topic, electrochemical series. Then in a electrochemical cell, anode will be there, cathode will be there. Because of spontaneous redox reaction here, electricity is produced here. Then in this, zinc is act as a anode, copper is act as a cathode. The question is, why zinc only act as a anode? Why copper is act as a cathode? Then we can understand this one with the electrochemical cells. Now we need to calculate the electrode potential, standard electrode potential of copper and zinc. Which one we need to calculate the standard electrode potential? The single electrode potential we cannot calculate directly. Yesterday we discussed. The single electrode potential can be calculated by using reference electrodes. Here we have two reference electrodes, hydrogen electrode and calomel electrode. By using reference electrode, we can calculate the standard electrode potential. Here are given 5 examples. Lithium reduction means gaining of electron, lithium plus 1 gaining of an electron, giving lithium solid substance. So it is a reduction. Here during this reduction, reduction potential value is minus 3.05 volts. So this is the reduction potential value is minus 3.05 volts. If it is a oxidation potential, then it is a plus 3.05 volts. Reduction potential minus 3.05, oxidation potential plus 3.05. So reverse case value is oxidation, forward case value is reduction potential. According to IUPAC norms, we should take only reduction potential. Now lithium reduction potential value minus 3.05 volts. This we can calculate it by using the reference electrode, either hydrogen electrode or calomel electrode. Second one, zinc. Here it is a reduction, gaining of electrons. Zn plus 2 is converted into Zn. Reduction potential of zinc is minus 0.76 volts. Oxidation potential is plus 0.76 volts. Now, no need of this oxidation potential. According to IUPAC norms, we use only reduction potential. Next, the third one. Yesterday we discussed hydrogen reduction potential value. Standard hydrogen electrode potential value is 0.0 volts. Either it may be reduction or it may be oxidation, 0.0 volts. Next, copper reduction potential value is plus 0.34 volts. Fluorine reduction potential value F2 is converted into 2F minus, gaining of electron. Reduction potential value is plus 2.87 volts. So these are the reduction potential value. Now the question is, if we use these electrodes, if I use any two electrodes from this example, which one is act as an anode, which one is act as a cathode? So here one note, that is important note. Now higher the reduction potential, one is act as a cathode. At cathode, reaction is reduction reaction. That electrode is called oxidizing agent. Again, note one, the electrode which is having higher reduction potential, it is act as a cathode. At cathode, reaction is reduction. Now that substance is called oxidizing agent. Second one, lower reduction potential is act as an anode. At anode, reaction is oxidation. That substance is called reducing agent. Reducing agent means the substance which gives the electron. Oxidizing agent means the substance which gains the electron. Now, reduction means releasing of electron. Reduction means gaining of electron. Oxidation means losing of electron. Now, you see the example. First one, lithium, zinc is there. Lithium, first one, zinc, second one, lithium, zinc, both. If both are connected, if these two are connected, which one is act as a cathode, which one is act as a anode? Higher the value, one is act as a cathode. Lower the value, one is act as a anode. Here this is, you should take only reduction potential. Minus 3.05, minus 0.76. This is the minus value. Minus 3.05, minus 0.76. So this is the higher value. So higher value is act as a one is act as a cathode, lower value one is act as a anode. Second example, zinc and copper. Yesterday we discussed in the Daniel cell. Zinc and copper. Here zinc and copper. Zinc electrode potential value is minus 0.76. Copper electrode potential value is plus 0.34. So this is the higher value compared to minus 0.76. This is the higher value, plus 0.34. So this one is act as a cathode, this one is act as a anode. So copper is act as a cathode, zinc is act as a anode. Next example, hydrogen and copper. Hydrogen electrode potential value, standard reduction potential value 0.0 volts. Copper electrode potential value, standard electrode potential value or reduction potential value plus 0.34. So this is the higher value, this is the lower value. Higher value one is act as a cathode, lower value one is act as a anode. Next possibility, if it is hydrogen and zinc. Hydrogen here, zinc is here. Hydrogen potential value 0.0 volts, zinc potential value minus 0.76. So this one is a higher value, this one is lower value. So hydrogen act as a cathode, zinc is act as a anode. This is about electrochemical cell. if we construct any cell, the electrode which is act as a cathode, the electrode which is act as an anode, depends on these values. You need to remember few values. These are the important values of standard electrode potential. Next, prediction of occurrence of a redox reaction. Now we know the spontaneity of a reaction is calculated with Gibbs free energy change. Gibbs free energy change is delta G. For any reaction, any redox reaction, if delta G value is negative means that reaction is spontaneous. If delta G is equal to positive means reaction is non-spontaneous. This is from thermodynamics. Now, prediction of occurrence of a redox reaction. We are using the redox reaction to generate the electricity EMF. Now, for any redox reaction, possibility or spontaneity of a redox reaction, delta G value must be negative. The relationship between delta G and the E electrode potential is delta G is equal to minus NFE. Gibbs free energy change is equal to minus N number of electrons, Faraday and electrode potential or potential of a cell. If it is standard Gibbs free energy, standard Gibbs free energy change, delta G naught is equal to minus NFE naught, standard electrode potential. This is electrode potential, this is standard electrode potential. If it is electrode potential, Gibbs free energy change. If it is standard electrode potential, standard Gibbs free energy change. So, when delta G value will be negative, for example, n number of electrons, we can't change number, it is next Faraday 96,500, then electrode potential influence the Gibbs free energy. If the electrode potential value is negative, then we get the positive value of delta G. Then if it is positive value of delta G, the reaction is non-spontaneous. The cell reaction is not possible. When we get the delta G value negative, if E value is positive, then only delta G value is negative. Or E naught value is positive, then only delta G value is negative. So, for a spontaneity of a cell reaction, electrode potential value must be always positive. Then, see here, E value is always greater than 0. Then we will get a delta G value less than 0. Then only cell reaction is possible. This is the relationship between delta G and E. Delta G is change, Gibbs free energy change. E is electrode potential or EMF of a cell. Next important topic, Nernst equation or electrode and cell potential. We know that electrode potential depends on three factors. One is nature of electrode, second one temperature, third one is concentration. Again, electrode potential depends on nature of electrode, temperature and concentration of an electrolyte solution. Now we are discussing about the concentration factor from thermodynamic consideration. We know the general reaction here, reversible reaction. Small letters represent the concentration, capital letters here reactants, capital letters here products. Here A, small a and capital A. Small a number of moles of A, reactant A. Small b number of moles of B gives rise to reversible with the product. Small c number of moles of C, product C, number of moles of C. Next, small d number of moles of D, capital D. So here capital D, capital C are products. Capital A, capital B are reactants. Small a, small b, number of moles. Small c, small d also number of moles. Generally, to derive the Nernst equation, when the basic formula is there, here E cell is equal to E naught cell minus RT by NF ln product concentration by reactant concentration. ln is log to C. Now this is the basic formula. From this one we need to derive the equation for all the electrochemical cells. Now again E cell EMF is equal to standard E cell E naught cell minus RT by NF ln product concentration by reactant concentration. R is a constant in joules, T is a temperature. Next, N number of electrons, number of moles of electron, F is a Faraday, ln log base E, product concentration by reactant concentration. Now, E cell is equal to E naught cell minus, here ln log base E is converted to log base 10. Then you multiply with 2.303. 2.303 RT by NF log product concentration by reactant concentration. This is a product. Here concentration C concentration to the power of number of moles of C, concentration of D to the power of number of moles of D, product concentration by reactant concentration of A. This symbol represents the square bracket represents the concentration of A to the power of A small a, concentration of B to the power of small b. Next here R is constant, R is equal to 8.314 joules per Kelvin. Next temperature is 298 Kelvin. F is 1 Faraday. 1 Faraday is equal to 96,487 coulombs or 500 coulombs round value. Now, if we take this value 2.303 into 8.314 into 298 by 96,500, we will get the value 0.059. This value is 0.059. If it is, this value is 0.059. Then the formula is E cell is equal to E naught cell minus 0.059 by N log product concentration by reactant concentration. Now, we need to calculate the single electrode potential now. Single electrode potential is in a Daniell cell, anode is there, cathode is there. Now, one electrode potential we need to calculate. For that is called single electrode potential. For anode, now Zn is converted into Zn plus 2, releasing of 2 electrons. For single electrode potential, cell means anode, cathode will be there. Now we are going to discuss for zinc. Zinc electrode potential value. Electrode potential means always a reduction potential. Now E zinc is equal to E naught zinc minus 0.059 by N. Number of changing electrons here is 2. N value is number of electrons by 2 log product concentration by reactant concentration. Product is Zn plus 2, reactant is Zn. Product concentration by reactant concentration. Now, any metal in solid form of metal, concentration is taken as 1. Now, solid form of metal concentration is always 1. So, zinc is a solid which concentration is taken as 1. Then it is zinc is equal to E naught zinc minus 0.059 by N, number of electrons 2, log product concentration. Product concentration is Zn plus 2 concentration. Why is Zn concentration, metal concentration is taken as 1. This is equation 1 for single electrode potential for anode. Next, for cathode. Cathode is Cu plus 2 is converted into Cu. Product is Cu. Reactant is Cu plus 2. Now, E copper. Here it is E cell. Here it is E zinc. Here it is E zinc. Here E copper is equal to E naught copper minus 0.059 by N. Number of electrons are 2. Changing electrons are 2. Log product concentration. Product is Cu by reactant concentration Cu plus 2. Again, metal concentration, pure metal solid concentration is taken as 1. This concentration is 1. Then the formula is E copper is equal to E naught copper minus 0.059 by N, 2 number of electrons, log 1 by Cu plus 2 concentration. This is equation 2. From equation 1 and equation 2, we will get this equation. So, anode is there, cathode is there. Then this equation for cell. So, anode and cathode. E cell is equal to E naught cell minus 0.059. Number of electrons are constant, either it may be anode or cathode. Anode is releasing of electron, same number of electrons gained in the reduction process. So oxidation, releasing of electrons 2, reduction, gaining of electrons are 2. So electrons are constant. 2 log product concentration. Here in a cell reaction, total cell reaction, Zn is converted into Zn plus 2. So it is a Zn plus 2. Cu plus 2 is converted into Cu. So Zn plus 2 is a product side, Cu plus 2 is a reactant side. So Zn plus 2 by Cu plus 2 concentration. At equilibrium, the Daniell cell potential value is 1.1 volts. At equilibrium, potential value is equal to 1.1 volts. At that stage, E cell value is 0. The change in potential value is 0. So at equilibrium E cell value is 0 and product concentration by reactant concentration is taken as Kc, equilibrium constant with respect to the concentration. So this one is taken as a Kc. E cell value is 0. If E cell value is 0, then E naught cell is equal to, this reaction is other side, then minus become plus. Then equation is E naught cell is equal to 0.059 by 2 log Kc. So instead of 0.059 we can take this value also, 2.303 RT by F. Already N is there, so NF log Kc. This is the Nernst equation, relationship between E naught cell to Kc, log Kc relationship. From previously we discussed about delta G naught. Delta G naught is equal to minus NF E naught. If we substitute this value here, we will get the value equation delta G naught is equal to minus 2.303 RT log Kc. 2.303 RT log Kc. Now, here this is log base 10. When log base 10 is converted into ln, then the 2.303 is removed. Then delta G naught is equal to minus RT ln Kc. This is about Nernst equation and application single electrode potential. Now, tomorrow we are going to discuss about the next topic, about the numericals on Nernst equation and the batteries. Thank you.